Alrighty, how's it going, everybody? Back at ya. We are finishing up the 10B quiz review worksheet. We did 1 through 7 in the previous video. Now we are finishing up 8 through 13. We're going to jump right in and start with number 8. We would like to find the area of the circle in terms of pi and round it to the nearest tenth. So remember, in terms of pi means leave the symbol in, round it to the nearest tenth, use your calculator's answer for pi, which is 3.14159265385, something like that. Not important. So we know the diameter in this circle is 24. Half of the diameter is the radius. So the radius we would like to use is 12 meters. So from there, we just need to use pi r squared, where we use the radius as 12. So 12 squared is 144. So 144 pi meters squared. Don't forget your unit. Now we need to convert that and round it to the nearest tenth. So 144 times your calculator's answer for pi should get you right around 452.4 meters squared. So that's number 8 done in its entirety. Number 9, here we need to find the area of the sector. And this time it's just in terms of pi. To do this one, we need to set up another proportion like we did for number 7, except it's going to be just a little bit different. So we still have that same format. Degrees over 360 equals, we're calling x the area of the sector, the thing that we want to find. And then this time, instead of over 2 pi r, we need to put it over pi r squared. There we go. Here the radius is 12, so that means my area of the circle is 144. So I'm going to draw an arrow. So I got 135 over 360 equals x over, like I said, 144 pi. I'm not going to worry about units just yet. I'll throw them on at the very last thing that I do, which is the answer. Now, if you can reduce the fraction on the left, do it. It's going to make life a whole lot easier. Whenever you plug that into your calculator and reduce that, you should get 3/8. So 3/8 equals x over 144 pi. And from here, we cross multiply. So 8x equals 144 times 3, which is 432. So 432 pi. Here we divide by 8, and we get x is equal to 54. Not a very good looking 5, but it'll do. So 54 pi, because we're leaving it in terms of pi, and now we include our units. Inches squared. There we go. Number 9 done. Number 10, we need to find the area of the composite figure. Again, a composite figure is a bunch of shapes put together. To find the area, we got to take the area of each piece and add them together. Now, let's start with a triangle. Hopefully we know the formula for a triangle by this point. It's 1/2 times the base times the height. So it's 1/2. Our base is 24. Here we have to be careful. You see that 8 there, part of the semicircle. That 8 represents the radius. In order to obtain the height of the triangle, we need to find the diameter of it. So we actually take 16 instead of 8. So when we multiply all of these together, we get 192 inches squared. So that's the area of the triangle. Now we need to find the area of the half circle. So I'm going to write half circle. Since it's half a circle, we have to take half times our pi r squared. Yikes. Hopefully you can tell that's a 2. I didn't do a very good job at writing a 2 for the squared there. Okay. Yikes. There we go. So we have 1/2. Radius is 8. 8 squared is 64. So 1/2 times 64 pi. Half of 64 is 32. So we have 32 pi. And if you want to convert that in terms of pi, or not in terms of pi, use your calculator's value for pi. There we go. That's what I meant to say. You should get right around 100.5 inches squared. So we're going to take this guy and this guy, add them together. So 192 plus 100.5 will get you an answer of 5. That's a 292. 292.5. So right here, 292.5 inches squared. That's what we want. Number 11 now. Find the area of the shaded region. So here we have another composite figure. Here we have a rectangle and we have a triangle. We need to find the area of each, and instead of adding them together, we have to subtract them because not everything about that is shaded. So let's start with the rectangle. That's the easiest. Man, this marker is really not wanting to work for me, is it? So base times height, 18 times 6 equals 108. So 108 meters squared. That's the area of the rectangle. Now you gotta do the triangle. Base is 24, height is 24. So we take 1/2, 24, 24. Plug that into your calculator, you get 288. 288 meters squared. And now we need to subtract the two. Take 288 minus 108. So 288 minus 108. And we get 180. 180 meters squared. That's the area of the shaded region. 2 more problems, folks. Number 12 and number 13. Let's do number 12. Number 12, find the probability that a randomly chosen point on the number line below lies on the given segment. We're going to start with letter A. FG. FG is right there. To find that, we do 6 minus 5. That's supposed to be a 5. I apologize if you can't read that. 6 minus 5 over 10 minus 0, which is 1/10. As a percent, that's 10%. Letter B. D, J. Excuse me. Here's D. Here's J. To find this one, we take 9 minus 3. These are the positions of the numbers. Over 10 minus 0. That's supposed to be a minus. There we go. That's 6 over 10, which is 60%. That's A and B. Last one, number 13. Find the probability that a randomly chosen point will be in the shaded region. So first we need to find the area of the shaded region and then compare it to the circle. Let's get started, shall we? We need to find the area of the circle. That's supposed to be an L. There we go. And then we need to find the area of the triangle. And then we need to subtract the two that we find. Here the radius is 4. So we're going to take pi times 4 squared. That's 16 pi. We're going to go ahead and convert that to a decimal, which is 50.3. So that's the one we want to use. Find the area of the triangle. You have 1/2 times the base, which is 4. Now, you might be asking, what's the height? The height actually is the diameter of the circle. So it's 8. So the area of the triangle then is 16. To find the area of the shaded region, we subtract them like I mentioned. So we take 50.3 minus 16. Plug that into your calculator, you get 34.3. 34.3. Go ahead and throw your units on there. 34.3 centimeters squared. Now we got to find the probability. Let me go ahead and label that probability. We need to put the area of the shaded region. So shaded region over the circle. The area of our shaded region, what happened? There we go. The area of our shaded region is 34.3. Divide that by the area of the circle, which is 50.3. When you divide those out and then multiply by 100, you'll get a probability as a percent 68.2%. That's the probability that a randomly chosen point will lie within the shaded region. So that is numbers 8 through 13. Thank you guys for watching. If you've got questions, send the geometry teachers an email. If you'd like to Zoom, let us know. Otherwise, we will leave you to it. So thanks for watching. Happy studying. See you later.